Hi, my name is Erin Kozel, and I'm going to be looking at a basic bread recipe to determine the functionality of various ingredients that are essential to bread. So to come up with a neutral recipe, I looked at a farmhouse loaf, an English farmhouse, an Old Betty Crocker recipe, and a traditional Amish white loaf, and used the baker's percentage method to come up with the typical ratio for each of the essential ingredients. It's going to be very involved in a recipe. A small amount of the sugar will be consumed by the yeast, which we will add later. Sugar is a carbohydrate, so it's easier for the yeast to digest because it requires less steps to break down than the carbohydrates you would find in flour. I'll talk about the reactions with the yeast in a moment. The leftover sugar, since only a very small portion will be consumed by the yeast, is called residual, and it will participate in many reactions to affect the taste, texture, and preservation of our bread. When baked, the sugar will caramelize and undergo Maillard reactions. This gives the bread its characteristic aroma and brown crust. The more sugar we add, the darker the browning. During the reactions, proteins and sugar will interact, forming rings. These complex molecules give the rich flavor found in cooked meats and bread. Sugar also caramelizes in the oven at temperatures above its melting point, which is a little less than 350 degrees. This process makes the crispy crust, which will, like a shell, help to retain moisture and preserve the bread over time. Finally, the sugar will make the bread tender by competing with the flour for water molecules. This breaks up the tough gluten networks, slowing their development. Too much sugar, though, will prevent the dough from rising. So we're going to dissolve the sugar in warm water. I have here about 1.25 cups of warm water. It should be about 110 degrees Fahrenheit because this is the temperature that yeast proliferates best at. Yeast is activated by the warm, moist environment. The water is going to not only just hydrate our dough, but it is going to interact with the proteins in flour to build gluten networks. It will also work with the yeast, as I mentioned before, in the fermentation process. This is the dormant yeast. You can see that it has been dried out. We're going to go ahead and add it to the water, and because the yeast is a living organism, it will begin to digest the carbohydrates. In our recipe, this is the sugar and the flour. The fermentation process, that is the digestion, will produce carbon dioxide, which will be trapped by the gluten networks that we will form in our dough. And this will cause the dough to rise. Like the sugar, the salt adds flavor and can disrupt the yeast activity in large quantities by drawing away moisture. But unlike the sugar, the salt adds toughness to the dough by tightening the gluten network. The tough gluten network can trap carbon dioxide, and this gives the dough more volume and allows it to be less sticky when we add it. Also, like the sugar, since it draws in the moisture, salt will help preserve the bread, so it doesn't have to be eaten the same day. We're only going to use a small amount of fat. Here I'm using oil, but you can use shortening oil, butter, and the fat prevents the formation of the gluten network. The oil shortens the dough by disrupting the hydrophobic and hydrophilic arrangements of the proteins. These disruptions break up the gluten networks, and it results in a more tender bread. Too much fat, though, and your dough will just fall apart. Add all of these ingredients into my polka dot stand mixer. And as you'll see in just a moment, our yeast, because it has been in a warm and moist environment, has already begun to produce some carbon dioxide bubbles. So we know that it's been activated. Go ahead and stir up our ingredients a little bit. But now it's time for our final and all-important ingredient, and that is the flour. So this is what's going to give us our all-important gluten networks that I've been talking about. The networks are formed by the binding of gluten and gliadin, which are proteins found in the wheat kernel, which is what flour is made from, and they're going to bind into long elastic coils, and that's going to give us our strength and structure to our dough. So in order to have that strength and structure, we need to have lots of proteins. And so for that, we're going to be using bread flour, and this is unbleached bread flour. And that has the highest protein content of available flours. So we're going to get those nice strong structures. These structures also help to trap carbon dioxide, which our yeast has been forming, and it's going to trap them like bubbles in balloons, and that's going to give us our traditional bread structure. So I'm slowly adding the flour to the mixer, and the mixer will incorporate this flour throughout the whole dough, allowing the water and the flour to form those gluten networks, and all of the ingredients to interact. As you can see, I'm mixing the bread with a dough hook. This is going to actually knead the dough, and that's going to stretch and align those gluten chains from the flour and the water, and it's going to build strong bonds. So as you can see, the dough has become both strong and elastic from those gluten chains. So I'm going to put it in this bowl here and let it rest. I'm going to put it in a warm and damp place, and there the yeast will consume carbohydrates. So my dough has been sitting under this damp towel on an oven vent for the last hour, and as you can see, it has really expanded in size. So what I'm going to do is punch the dough and then go ahead and re-knead it, and this will redistribute the yeast and the yeast food, so the various carbohydrates, and that's going to give us a better flavor. And I'm also going to knead it to realign the gluten networks, and that will just give our bread a little bit better texture. So I'm going to go ahead and punch it, and I'm going to pull it out and knead it. As you can see, my dough has dropped back down in size, and that's because I broke up those carbon dioxide bubbles that had formed by the fermentation of the yeast in that first rising. But now that I've redistributed the ingredients, the yeast can produce more CO2, and so we will let the dough rise again. We'll go ahead and set it in the dough pan to let it rise so that it is ready to be baked. After my dough had risen, so I went ahead and put it in moist environment again to oven. I do have a breadstone, but I did not use that for this application. I baked the bread at about 350 degrees so that those caramelization and reactions could occur, and obviously the yeast would be killed because the temperature is about 140 degrees, so all of those reactions can take place. So I just cut off a piece of my bread, and as you can see, there's lots of small spongy texture, and that comes from the gluten networks from the flour and the water, and the carbon dioxide produced by the yeast. As you can see, they're pretty small texture. That happened because we punched the dough and kneaded it again, so that broke up those big bubbles, redistributed to give that finer texture. And as you can see, I have this brown crust here from the caramelization reactions, and it's still spongy, but the crust is pretty firm and crunchy, and that will help to preserve the bread from losing moisture before I can eat it. So that is all. Thanks for watching.